Hey, good morning, all of you. Welcome to. Is this week four or five? I think it's four, isn't it? Four. Great. Okay. So week five is when we have, typically talk about functions and all. I mean, we've been using functions already in the first few classes, but it is some students are not used to it, so we kind of backed off. But really speaking, it's simple. Okay, so we'll get to know more. We'll know about next week. We'll know more about what goes on in the background, right? When people call functions, because we know how to use functions, but we don't know how functions do their job. Yes. Okay. So next week, and knowing how functions do their job is key to understanding how to implement and use functions well. Yeah, just like a manager, right? If a manager has no idea how their subordinates are working, they're not going to do a good job. They need to know how something is done before they can tell someone this is how you do it, and please go and do it, right? Otherwise, you have no way of knowing whether the job was done well or not. So just like that, we're going to learn next week about functions and what goes on inside. But by the way, I wanted to start off today, while we're waiting for other people to join, the activity on in the forums is not high at all. It's very minimal since last week, so other than this one person, I think probably not even a student. There's some username called visible something, visible light, or I don't know, visible simple or something like that. Yeah, not even a student, and they're making posts, and you guys should be making posts too, right? So you should be making posts. Also, I need to make another kind of announcement, like for participation points. When it comes to the end of the quarter, I think I already mentioned that the participation points will be determined by a report you will submit of all the posts and comments you've made, and just like an essay. And that needs to be good, okay? You can't just bunch up like 4 or 5 posts you did in the last few weeks and say, oh, wow, this is my report. Yeah, you'll get 2 or 3 points out of 15 for that, right? Also, the other thing that will increase the chances of getting participation points is making posts that are relevant to what we're learning in class. Absolutely, you can make more other posts that are not relevant but also interesting to the larger scheme of what we're doing. Like Hannah made a post. Where's Hannah? Yeah, with that SDL based game, not STL, SDL, that snake game or something like that. That's all really cool. It's cool, but it doesn't really contribute to participation points in our class. Okay, at the end of the quarter, what I would look for in the report that you submit is not posts that are extraneous to what we're learning, but really stuff that we are learning and helping other people. More importantly, there's all these, if you're stuck for topics, there's so many questions, interesting questions that I sprinkled through the quests, the specs, right? If you're reading the specs, if you skip right through the mini quest, okay, I'm going to do this off, check this off, do this, you'll never get a chance to get participation points, because all of the interesting questions that are thought-provoking, that invite you to take a stab at a guess, and this is what I think goes on, this is my reason, and so on. They're buried in the spec where we talk about certain things, and these questions will get more and more frequent as you do 2B and 2C. Certainly in the later half of 2A also, you'll see more questions. Those are all interesting discussion points that you can pick up and start a discussion thread in the forum. Say, hey, I saw a question in the spec, and here's my guess, what's going on. The other thing that is really, really important to get participation points is, I'm giving you lots and lots of opportunities in class to start a project, okay, and take it almost all the way to the end and say, well, this is to do, you got to wrap it up and post it in the forums, okay? Those are all great. So I think Erica, Hannah, Namrata, All right. And these are people that have actually taken up these opportunities and posted things. You know, Omar, where the hell is Omar gone? Right. So Omar's right. So he was there too. These are the things that you should grab and say, well, you know what? I'm going to take that thing that we worked on in class, and here's my take on it. Right. Here's my version of the MFA heaven game, like Erica or Namrata posted. Right. So those are the things that will get you points at the end, not just a list of things. Oh, you know, yeah, that doesn't get any points. Just like if you go to a, you know, an English class and say, well, you know what, at the end of my quarter, here's a list of 15 poems by Robert Frost. Okay, you just Google and say 15 poems, and those are my links to, you know, where I found on poetry.com. Okay, no points for that. Right? The English teacher will say, what is it? What is it that Frost is trying to say about the wall in that poem? Right, and so that's what you get points for. Please keep this in mind as you work through you know, forum posts and all. Today we have Charlene, who I think volunteered last class to code, and also before we start coding, let's also line up someone for Thursday and next week. We'll keep it in mind. So raise your hand if you think that you would like to code either today after Charlene is done with our first you know, program. You can step in and start coding today, or you can line yourself up like Charlene did for next class on Tuesday. You know, I'd like to code on screen live next Tuesday, next Thursday or next week. So raise your hand and let me know, okay? And then we'll line you up. Hey, Charlene, you're here today, right? You're here and you are set up to code, I hope. Yes, Charlene? And where's Justice and Justin? I don't see either of them here. I was actually hoping that Justice will be here because we need the code that he worked on last class. And you know, what is it? What did we do? The Price is Right? Did we do the Price is Right last class? Yeah, the price. I think we did the Price is Right. Where is it? I was hoping that we'd have the code. Does anyone have the code that Justin wrote? Anyone following along and coding simultaneously? You have, oh, Namrata, thank you. All right, so certainly we have the code. We can actually take a look at it, and let's review the code briefly. Before Charlene takes the screen, because I don't think she's here yet. Charlene, if you're here, you should, you know, switch on your camera or say something so we know we can start. Until then, maybe Namrata can share her screen. We can go over that code briefly. And yeah, we'll go over that code briefly, and I'll also point out. For, you know, getting points and all, or making posts on Reddit, we're going to be doing some code in class today, and it's not going to be that code. We'll do something else today, but doesn't mean that you should only post in the Reddit on what regarding what we're doing in class today. No, what we did previously also is game. So you can go to the, you know, Erica's post from before, Namrata's post, or, you know, or this thing that Justice did last class. What is it? The Price is Right. You can say, well, you know, even though we worked on something else today, I took a different take on the Price is Right, and here's my version of it. In fact, you know what? This Price is Right. Well, you know, yeah. All right. So here's something really cool. You can actually let's turn that Price is Right game. Well, after Namrata shares the screen and we go over this, I think I can suggest a way in which how many of you have, you know, Google Home or Alexa or, you know, or Apple Pod or something like that at home? Raise your hand if you have one of those assistants. You know, you just go to Best Buy. It's like $40, $50, and you just plug it into the internet. It's actually very cool and handy. If you can, if you like these kinds of things, because lots of things that you would go to Google now, and in the past, okay, even last year, I remember, right? If I had a question, I had to go to Google or, you know, Bing and type it in and say, okay, you know, what is the population of Mozambique, current population of Mozambique? I don't know, right? But I'm interested, and so I have to type it in. But now I don't have that problem at all, right? Because it actually does save you a great deal of time. Because imagine, right, just going to a computer, typing it in, looking at the result, that takes about 10 minutes. Yeah, 10 minutes. Well, you know, not 10 minutes, maybe, all right, it takes about 4 minutes or 3 minutes, okay? It takes that time. But now with these things, these things are only like 15 seconds. Well, you know, this thing it saves me 10 seconds here, 10, 15 seconds here. It's like money. It just keeps adding up, even though you don't know it. And at the end of the day, you actually find you do have a couple of hours free. that you would have otherwise wasted by sprinkling around, asking these questions and going to a computer and typing these things. Now today I can just ask, right? Actually, famous last words. Let's actually try this to see if it actually works. But I think it'll work, right? Because these questions, I've tried many of these questions. Not tried. I'm actually using many of these questions, and it actually works. Let's try this, okay? Hey Google, what is the current population of Mozambique?
In 2021, the population of Mozambique was 32,077,070.
Yeah, okay, good. All right, so it's about 32 million, right? And if any of you have these things, the reason I said get these is not just to get used to these things and saving time at the end. It actually opens up the opportunity for you to play with programming in a useful and fun way, because this Price is Right game, I'm not going to do it, obviously. I'll show you a way, or I'll suggest a way in which you can turn this into an Alexa game or a Google game or a Siri game that people just sit in their couches and play with their families or friends. They have them over for dinner. They're all sitting around, and maybe we turn this game, not Price is Right, the number is right. Okay, let's say it's the number is what is your number? Let's call it, what's your number? Like, you go on a date and say, what's your number? We call this a game, what's your number? And and I think the way this can work is, even though you ask, you saw this thing, right? When I say, hey Google, what's the population of Mozambique? It gives you this full sentence, but really it is not that full. That full sentence is not what you get from the API call. So the API calls are all of these services like speech recognition, natural language understanding, mining data to get numbers and data out in like this question, right? Say, what is the population of this country? And it gives me a number. So it doesn't come to me. If I was implementing that service on Google Nest or Alexa, I wouldn't be implementing it in C++, actually making that API, these things, all of these things.
Democrats maintain their majority.
Alexa, stop. Every time I say her name, she kind of says, I think I'm talking to her. Okay. No. So, what was I saying? Yeah. So even though it comes to us in the form of a full sentence like this, and you think, well, you know what, I got the answer, but I have to extract the number 32,743 out of that full sentence, and I don't know how to do that in C++. Actually, the way that it works, all of these services, they've been hacked up by these companies, is that they don't give you that full sentence, right? If you ask what's the population of Mozambique, they'll just tell you that raw number, 32,745. It'll just come to you like a number, right? Alexa or whatever it is. And then the service that you will be
specific song.
Alexa, stop. I have to remember not to say her name at all.
Here's a station for you based.
Alexa, stop. Okay. Okay. Right. So what they get the number, and then they have a natural language synthesis, right, service that'll say form the answer to the question using this number slotted in. So they slot in the number in a sentence, and then they speak the sentence out to you, right? I say, I've got the sentence, now turn the sentence from text into voice, and they play it out. And then this is not done using C++ or anything. They have a very simple language, I think, right? I don't know how they did it. If I did it in these companies, this is how I would have done it, right? They have the backend service that just does the API call to get the raw number out, and then they have other API services. Now I've got the number. Now you go and stitch this number into a sentence and give it to me. All right, now I've got the sentence with the number slotted in. Now you go, the third service, right? You go and turn this into a audio waveform that I can play on the speakers. Okay, that's the answer. So all of that happens, and it's just a scripting language. Right, a scripting language is where it's like Python. Well, it's not even like Python; it's more like English now, right? So you can, it'll be a scripting language where you would get what the user says. In fact, we did something like this when I taught cloud, AWS cloud, many years ago. We actually did this. In fact, it might be recorded. If you go to our nonlinear media channel and you look at the recordings and go all the way to the back, you'll see that. I organized something called the Cloudathon. This is when I taught cloud. I organized something called Cloudathon at Foothill, and at the Cloudathon, all of the students in my class who had been working on individual cloud projects, they get a chance to demo their stuff, right? And in this Cloudathon, some of the students wrote projects that would interact with the Alexa service in the backend. And then get the answer, and it's all very nice. In fact, the question number 5, I think you do Eliza, right? You're talking to the computer, and it'll give you answers back, right? You're talking and giving you answers back, and you do it by text. So one of the cloud students, or actually several of them actually, did a verbal version of Alexa of Eliza, right? Yeah, she picked up, even though I just said half her name, right? So they actually did a verbal version so that you can play that game, Eliza, just by sitting down and talking to the computer and saying, Eliza, I'm feeling bad, and then what the program would do. That this is a program that my students wrote, right?
I missed something. Can you say it again?
Alexa, stop. I think what's going on is that it is misrecognizing Eliza to Alexa. Every time I say Eliza, it's picking up. Okay, well, not this case, right? So what they did was the students did was you just speak, and they capture the waveform, and these services, they can capture the waveform, and then they take the waveform and send it off to another free service, right? Not free service, another service just on Amazon. What was it? I think it was called speech recognition. I don't know what the name of the service is. It's called speech recognition service. They'll send the waveform over there, and then and it's very simple in the scripting language these guys use. It's very simple. It says, here's a waveform, decode it for me. Right, and then the next thing you get is a response back from the service saying this is a decoded waveform, and it has the English text, right? And then you can take that English text and you make another API call, again, just like in an English-like language, scripting language. Say, I've got the waveform, now go and understand the waveform and tell me what they want, okay? Or extract the nouns and verbs from it. All of these can be done, right? And it'll come back with an answer. And you take that, stitch together your response, like you do in Eliza, question number 5, and say, well, I've got this response I want to speak back. Now I'm going to send it to Polly. It's called Polly. Okay, Polly, can you make this into an actual speech that can be played on a speaker? Okay, and I'll say, okay, I've taken your sentence, I've turned that into a speech waveform. You can play it like an MP3 file. Okay, that comes back to me. All of that happens within 1 second. Okay, so you get the waveform, transcode it, and everything happens in 1 second, and then you get the waveform and play it back, and they were able to have a conversation, right? These students were able to have a verbal conversation with an application they built in Amazon Cloud using these, and so you can do this. So I was thinking, if you guys are up to it, maybe not in CS2A, but you can turn this into what's your number, a game that you can release, right? You can release, and I'm pretty sure that lots of people would just like to just download the game. Don't price it, don't say it's 99 cents and all. I think there's free apps, or maybe some of these stores will say your app has to cost at least 49 cents because they don't make a profit, right? So I don't know, price it as low as you can, release it. I'm pretty sure that a whole bunch of people, especially when holidays are up, they'll just say, hey, let's play What's Your Number by Erica, right? And they'll just download the app to their devices, and they'll just play on Siri or one of these devices. And the way this will go is that you can ask, well, hey, Namrata, whenever you're ready, you can share the screen, and then we can go through the code, and I can point out places where, hey, we can do these things. In fact, you know what? Let's go over this code, and then we'll just do another version of just pseudo code, okay? Not C++ code, just lots and lots of comments. And in the comments, I'll say, this is where you're going to make a call to that service, right? Backend service. And you can basically just look up on the net saying, this call needs to be made in AWS. How do I do it, right? This call needs to be made in Google API. How do I do it? And you'll find examples on Stack Overflow and all these things. You just have to stitch these things together, and you have a game. Okay, so we'll try that. Okay, so what are we doing here? Can you? All right, we get a number, secret number. Okay, now I'm going over this just to refresh my memory, but obviously it should not just be me. Okay, every one of you should also be looking at this code, and if you have any questions, not sure what's going on where, this is the time you should ask. Okay, and then we'll clarify these things today. So we can't use functions. Functions are until next class. No, functions are next week, is it? This is week 4. Okay, what can we do? All right, so we'll come up with some idea, right? Unless, do you have any cool ideas that doesn't involve functions, but involves arrays, iterating, loops, branching, all of those things? If something fun that you can implement using these things. We have time, a few minutes while we review this code. Think about it, and if you have a good idea, we'll implement that, or else I'll try and see if we can come up with an idea. All right, okay. So we get a vector, an array of player names. All right, these are parallel vectors. Yeah. Okay, so scroll down. All right, so we're asking the user for the name. Okay, and get the name. Everybody okay so far? All right, so we're getting the name. Okay, so further down, I see. So we're taking the name and the guess, and we're just putting them in the two arrays. We have two arrays next to each other. We're putting the name, their guess, name, their guess, name, their guess. We're basically stuffing the two arrays parallelly, right? So which means parallel means every element has a corresponding element. Okay, there's no element that is not matched. So we have this. We're all right. And then what we do is, do we ask the user? Oh yeah. We get the guesses, and then we compare the guess with the secret number. Okay, and the person that's closest to the secret number is, yeah, I think that's pretty cool, right? It's very simple. It's a very simple game. And I think, does everybody understand how this game works, and the logic and the C++ for this? I think we can move on from this. In fact, Namrata, when you're done with this, open a brand new project, and then I'll just walk you guys through the pseudocode for what you would do if you were doing a Google app or an Alexa app, right? So I'll show you what you have to do when you do that. Okay. All right. So is everybody okay with that code so far? That's basically is it. That's all, isn't it? That's the cycle. If once you're in there, we're done. Okay. So so let's put a comment there saying this is a side project unrelated to CS2A. It's a suggestion. A suggestion for people to hack up on what do we call these things? Home assistant pods. Okay, like Siri, Nest, etc. Okay, using their scripting language, not C++. Okay, using their scripting language, and within brackets you say not difficult like C++. Okay, so within brackets you say not difficult like C++. Okay, well, I shouldn't say not difficult like C++. You say not like C++. C++ is not difficult, right? C++ is just a different language. Okay, you get rid of the word difficult if you don't mind. All right, so yeah. Not like C++. Okay, thank you. All right. So all right. So here's what we're going to do. And we don't have main. Well, let's do a main. Okay, just say main, no int and all, right? So or you say int main, right? So just do a main, and inside of the main we'll have the logic for this, right? So what do we do in this game? So let's say we're playing this game, and the game has been started off. Let's say we say, hey Google, start the game. What's your number? Okay, and then it says, right, so yeah, now put a comment there saying after the game has been started, by the let's say Nest pod or something like that, or by Alexa, just say Alexa, by Alexa, right? For example, within parentheses, because it doesn't have to be Alexa, right? It could be anything. Right. So on the next line, you say greet the user, right? Greet the user. Greet the user. Okay. So now by saying something like hello, Namrata. Welcome to what's your number? Welcome to what's your number, right? Okay, and then the next thing it has to do is we need a bunch of questions that what we need are questions that have numerical answers, right? Well, let's just do numerical answers because it's going to be easy. So what are things that might have numerical answers? Well, what is the population of Mozambique is one, and you could say how many, how many blue whales are there in the ocean, right? What is the mass in kilograms of a great white shark, right? Or how many windows are there in Seattle? It's this famous question that used to be doing the rounds, right? How many windows are there in Seattle? So mass you can just come up with a bunch of questions, maybe 15 or 20 questions, right? And then you can keep expanding the inventory of these questions on your own, or you can even look for questions online, right? Now on the next line you can and put ellipsis, right? And ... So you have many questions like that, right? On the next line, on the next line you can say ... Okay, so now you're going to say select a random question. How do you do that? All you have to do is maintain an array of these questions. Maintain an array of these questions. Pick a random number, random index in the array. You know how to do, everybody know how to pick a random index in the array? Yeah, random, modulus, size of the array. Yes or no? By the way, you got to tell me if I'm speaking too fast or things are going fast, right? I know Namrata is typing fast, but I want to make sure that everybody is on board. Okay, is everybody on board? Raise your hand. Nobody? Simon, are Simon, Charlene, are you? We're going to come to you, right? We'll start coding a game as soon as we're done with this. Okay, 5 or 10 minutes, I think we'll be done with this, right? Everybody okay or not? Right? All right, good. All right, so so we pick a random question, and then we're going to, on the next line, we're going to say, pick a random question, right? Random. All right. Now on the next line, we're going to say, send a call to the Alexa API, right? API in uppercase, Alexa API, right?
Sorry, I'm not sure about that.
Alexa, stop. Maybe I need to switch her off for, the duration of this class, right? And within parentheses, you got to say, look it up. It would be like a scripting language, okay? It'll be a simple scripting language. Yeah, a simple scripting language. Yeah, all right, good, right? to turn that question into an MP3 sound, into an MP3 sound. All right. Okay. On the next line, you're going to say, play the sound. Play the sound on the device speaker by issuing another API call. Right, and change the word sound into question. Right, play the question on the device speaker. So at that point, the device would have asked the player, what is the population of Mozambique? Okay, now on the next line, you can say, now go through all of the players in the room, asking them for their name and their guess. Okay, so you'd have a loop there. On the next line, you say, in a loop. On the next line, so on the next line, you can say, number one, ask the user, what is the first player's name, right? What is the nth player's name? Because you're going to keep a counter called n that keeps incrementing. But you can say, well, enter your name. Well, what is your name, player? Right? You can say, what is your name, player? You prompt and get the name, right? And then on the next line, ask the user for their guess, right? Ask the user for their guess. Again, this will all be coming to you in speech, right? In voice. So you got to get the waveforms. Again, you'll get these waveforms here. Send the player's name and the guess to the device API to get the text version, meaning to decode it, right? So it'll say, well, the name of the player was Namrata and their guess was 47,000. Right, you'll get those two numbers from the API call. The script, if you look it up online, they'll tell you what you need to do. Right, here's the waveform, send it, you'll get the text back. Here's the waveform, send it back, send it there, you'll get the number back. All right, maybe you'll get the string of a number. You need to convert that using some, convert string to number, like we've been doing. All of that available. Okay, now that is in a loop. And you're going to say, where you put the first loop on line 25, hit enter and say, if the player's name is no more players. If the player says no more players, then break out of the loop, right? No more players, break out of the loop. Right? Now, loop. Yeah, loop. All right. Now, after you've broken out of the loop, you have all of the players and all of the guesses. Now you do what we did last class, right? Because we've done the API call. We know what is the actual population of Mozambique because it was returned to us. And now you have the guesses, various guesses. Now you can find out, right? Just you're doing using the logic from the previous class, figure out which player is the winner. That is pretty straightforward, isn't it? Because you just have to find the difference and find out who the closest is, who the winner, which player is the winner, right? And then on the next line, you're basically just going to say, announce the winner, congratulate the winner or whatever it is, and also announce the actual, announce the winner and the actual answer. Right, and the real answer, winner and the real answer. That's all. Okay, and the whole thing, and put the whole thing in a loop. Oh, actually, that's it. That is one thing, right? So because they're all sitting on a couch, they could basically say, play a game of what's your number. He'll do one round and it's done, right? And you want to do another game, you can say, hey guys, you want to play another game? All right, so you say play a game, and you can keep doing that again and again. And that's all, right? It's a very simple, tight, scripted loop, right? Within which you have this game, and you can easily program this, right? And again, this goes to show that you already have all the tools and the skills necessary to craft a real game that you can release into the wild. That's, this is incredible, isn't it? Today, if you have all the skills from last class, you know how to do these things, and well, maybe it'll take you a day or so, just because they have the scripting language. It won't take you as long as C++ to master, because the scripting language is basically just saying, these things only have like 30 or 40 services that you can hit, like the speech, comprehension, transcribe into voice. It's very poly and things like that. And each one will be very well defined, and saying, well, if you call this is what it'll do. If you call this is what it'll do, right? There's documentation. And so it's not going to take you a long time to master that, because just learning this. And so you can actually program this and release it and ask your friends and family and anywhere in the world, right? If they have access to the internet, you can say, go to this device, download this game on Google and play this game, and they will actually be able to play it, right? And you can even put in your personal signature at the end saying, hey, mom and dad, I hope you like this game, right? And someone out there playing this game will say, hey, mom and dad, right? Okay, so all of that is really cool. That's all. It's, I'm not going to go do this, implement this right now, but I just wanted to put the framework out there so that you know how to do it, right? Once you've done it in one language, you can do it in any language you want. That's all, right? We did it in C++. Now you can do it in any language. And this language doesn't have to be, and can be a scripting language like these devices use. Okay, that's all, right? So is everybody happy with this? So this is something you can do. And if you do happen to actually implement a game after having done a little bit of research on these device APIs, find out, right? And you can post a link saying, hey guys, those of you who have Google Nest, download this app on your device, and this is a game that I implemented, okay? And you can play it. And I'll be happy to play it, okay? I'll definitely give it a whirl, and I will try it out, and I'll say this is fun to play and all, obviously. So that's all, okay? So we won't do any more here. So you can save this also, Namrata, and share this. Thank you so much, right, for sharing and also typing really fast. Yeah, because she typed fast. I don't know if I was speaking fast, okay? So someone has to keep telling me. Someone has to keep telling me, don't speak fast, speak slowly, okay? And I will be happy to do that. Okay, good. Now, Charlene, whenever you're ready, so you share the screen, and then if anyone had a cool idea for something that we can code today. Is everybody here? Why are people just dropping off? Are people just not? Is this class too hard? I don't know, right? Because people generally tend to sample classes in the first weeks, and then they try and this is a bad trend. I don't like this trend, but this is what it is. I don't know, right? So people tend to drop the hard classes. Right, in community colleges, they say, I'm going to enroll in these things, and I'm going to go shopping around, and then after the end of the first week, when it comes time to drop, I'll just drop off the hard classes and keep the easy ones, so that at the end of the quarter, I come up with good grades, A+ everywhere. Right? That is the exact opposite of what they should be doing to succeed in life. Because by doing that, they'll be succeeding in college by getting A+, but they're not setting themselves up to succeed in life. Life is where you need to get an A+, not in college. Yes. So the trick to succeeding in life is in college, when you have it easy, when the professor is looking after you, your classmates are looking after you, you have your parents and friends and everybody saying, we'll take care of you, go and learn. This is your first thing. This is the only thing you should do, because this is a chance you get to become successful later on in life. So you should drop all the courses that are easy. So when you have your courses set up and it's time to drop classes saying, I can only take this many units or this much money or whatever it is, right? You say, all right, which ones are the easiest courses that I don't, that I'm not likely to benefit from, okay? Not likely to benefit from. Those are the ones that should go, right? The ones that are hard, those are the ones you keep, because those are the ones that will make sure that you actually learn some really useful skills later on. It's the ones that, like, what is it, 2 explorers who went into the wildies trying to find new ground. What's the name of the people that acted in the Superman film? Clark Kent, and I don't know. There are 2 famous explorers in North America, right? Who are known for going into the wildies. They discovered new territory and all, apparently, but they only do that when you're at the fringe and you could encounter a grizzly bear anytime. Right? If you're safe in the comfort of your home, you're not going to discover new territory, right? Yeah, I discovered my room, my bedroom, or my kitchen, right? No, it's been there all the time. It's just that your mom was there all the time. You never went to the kitchen. Now you have to cook for yourself. You discovered the kitchen, right? No, so that's not it. You have to be out there and putting yourself at a little bit of risk, right? And not, I'm not going to go and be food for the grizzly bear, but you got to be aware that you could face a grizzly anytime. Right, and that is when you will actually also discover new territory. Discovering new territory in knowledge is actually fantastic. Okay, it is a rush. It is a total rush. It is a different feeling, and it is a rush that is completely distinct from discovering new territory out there. Right, physical territory. It's different. Right, even if you discover something new, a new ride in Universal Studios, yeah, okay, that is cool too. Right, but you can take that rush, right? You can take the rush of discovering the new ride and multiply that by 1 billion. Okay, that is the kind of rush you'll feel when you discover new territory in your intellectual ground. And you say, wow, you know what? He was there in my head all the time, but I never saw it. Right, because that is a truly surprising event, right? Because you thought you didn't have it, but you actually discovered you had it all the time. Right, and then imagine if you found it when you were 90 years old, or when you're just about to die, you find out that you actually had something you never used all your life. That would be the most disappointing thing for most people. Yes, because you said, well, if only I had discovered that when I was 10 years old, that my life would have been completely different. So all the time that young people have should really be focused on finding out every single talent they have that is hidden and not being exposed. You got to find out, and you can only find out if you're out there trying to hit it and saying, oh, I'm gonna peel away everything that I already know because I want to get to the core and see what is not there. Okay, or what is there but I can't see. All right, so I don't know where I was going with that, but essentially what we can do. Well, I was trying to think of what we can do today. So we want to build in some kind of randomness so that it's more like a game. And by the way, I'm trying to, obviously, right, if you guys want to do it differently, we can do it. The reason I'm trying to fit all these things that we're doing in class, like loops and all these, everything, all the rote stuff, into something like a game, something that's interesting, is so that, it kind of hooks people in. Because I know that when you're trying to study something, if it's dry like a biscuit, people are not gonna, it's tough as it is. People always, we're already, C++ is shouldering the blame that lots of people say it's hard. And then if you're gonna look at a, bone dry, boring program, that's enough to turn most people off, right? So that's why I'm trying to say, make these things interesting so that, but if you do want, right, if that is not your cup of tea, if you want to learn in a different way, which is like, oh, today we're going to learn about functions. So let's code 4 or 5 functions and look at these things. I'm happy to do that too, right? Or looping. This is the 5 different ways in which you can do looping, right? And do some examples of that. Yeah, we can do that too. But in my mind, I think that is less useful to students than if we actually built a little project that uses these things, right? But using things is when we actually get to know how these things actually work. Okay, so let me know if this is not the right strategy. We can change it anytime. Okay, we can change it anytime. I can teach in many different ways. I've taught that way too, right? In the past, I've taught like that, saying, oh, today class, we're going to learn about loops. Okay, let's look at 5 different loops, and this is the way it works. This is why this is different from that. Okay, what's the point, right? You need to know why it's different, and that's what we're trying to do. Let me know. All right, so I think I have an idea. If nobody else has an idea, this is what we'll do today, okay? But I won't tell you what my idea is until you guys have a chance to tell me if you have an idea that you want to code today. We can use anything in C++ except arrays, and well, we can use arrays, not functions, okay? Let's not use functions. We'll not use functions. Everything you've learned so far until arrays. If you have an idea, we'll do that. The idea I have in my head is there's a game, right? Something like the memory game that we did before. Again, something that relies not on memory this time, but some other kind of skill, right? Maybe eye muscles, finger muscles, that kind of thing, right? Maybe next class we'll do something that uses finger muscles. Okay, so people can play, and then the ones who have the fastest fingers will win, or something like that. Okay, something. Yeah, I think we tried doing that, something like that in a previous quarter. Did it work? I forgot whether it worked. But anyway, this time we will try it and see. I'm pretty sure, because it's not very complex and simple. We'll probably be able to get it to go this quarter. Okay, especially since I've done it last time. So I have some experience where students get stuck and all. So, all right. So if everybody is okay with that, and if you don't have any other ideas, Charlene will pick up the screen and go to online GDB or one of these sites, right? Whatever she wants, and then share the screen, and then we'll start coding this. Okay, well, how does it go? All right, so I'll explain how it is shaping up in my head, and you guys can either refine it or point out places where I haven't thought through clearly enough, so that we may need to fix it. And then, but I think it's workable. Okay, so here's what I'm thinking. All right, okay. We know how to use the clock and the time and things like that. Good. All right, so yeah, all right. So let's say we pick 100 random numbers. Okay, 100 random numbers between 0 and 1,000. Okay, 100 random numbers between 0 and 1,000. 100. Okay, 100. And then we will use the logic from, was it last class? I don't know whether it's last class. Find the minimum of those 100 numbers, minimum or maximum, whatever it is. Okay. So and I'll show you how to do this. You have an array of numbers. You have to find the minimum. You just have to go through the array saying, I've got the first one is going to be the minimum. I make my assumption saying the first is the minimum. Then I check the next one, right? Array index 1. Is that the minimum? Is that less than the previous one? So that's the minimum now, right? Next one, not less, not less, not less. Oh, that one was less than the one that we saw before. So this is now the minimum. So you're going to keep doing that until you get to the end of the array. When you get to the end of the array, you have the minimum of the array. Yes or no? Raise your hand if you think that logic is okay for just, picking the minimum. Yeah, okay. So we have an array of numbers and we just want to pick. All right. So now we have 100 numbers and the system, the computer has used your logic to figure out what the minimum is. All right. Now here is the game part of it. Okay. And I think this is going to be cool. Now you're going to print the 100 numbers like a matrix. Okay. 10 of those numbers, 10 numbers per line in 10 rows, right? 10 numbers per line in 10 rows. And we can also make sure that each number is exactly 3 digits long so that it looks like a square. Okay. So the minimum number in that matrix is hidden somewhere, right? It's not the first one or the last one. It's in there somewhere. Okay. Now you're going to say, after printing those numbers, the program is, hey, Charlene, you're going to be coding. Okay. So you should also raise your hand or something like that. So that, good. All right. So where's Charlene gone? She just disappeared. All right. Oh no, there she is. Okay. All right. So it's got to say, it's going to print those numbers and it's going to say, what is the minimum of those numbers? You have 5 seconds to find out. Okay. That's all. It's going to time, right? Because, the way we're going to do it, because of C++ and the command line nature of what we're doing, because, really interactive game, you can say you respond to keystrokes, but unfortunately we are constrained by saying we have to wait until the user hits the enter key. Okay. Now, let's assume that Jay is playing this game, all right? Or Sabrina, right? So let's say Sabrina is playing this game and the matrix comes up there and then there's a question, what is the minimum, right? You have 5 seconds. And from that point, as soon as you print that question, you're going to check the time, right? You're going to check the time, bam, like that. And now what is the minimum, the question, right? Now the Sabrina has all the time in the world, right? To enter the answer, and she says the minimum is 47, right? Because I see it right there, right? But the system knows the minimum already, and it's going to do 2 things, right? First of all, it's going to compare, is Sabrina's guess the right one? If it is the right one, it'll say, yay, Sabrina, you won this round, let's go to the next round. Okay, and we'll figure out ways in which the next round will be slightly more complex, okay, slightly more difficult, right? However, the other thing is that even if Sabrina was right, as soon as Sabrina hits enter, it's going to do a clock call one more time. Okay. Now it's got the time when Sabrina hit enter. It's got the time when the question was asked. Now the difference between those times is the amount of time Sabrina took to, move her eyeballs really quickly and find the minimum. Yes. So we know how long Sabrina took to find the minimum in that matrix of numbers. Yes or no? Yeah. Okay. So you can have 2 constraints. Not only should the number be right, you should also be have been given within 5 seconds. Okay. So if both of those are right, Sabrina advances to the next round. Otherwise, you say, well, Sabrina, you took 6.7 seconds, right? But you had to get it within 5 seconds to go to the next round. And it ends. Now you can put the whole thing in a loop, right? And then it'll keep doing that. And every time you advance to the next round, you can make it slightly more complex, right? Maybe you use 4-digit numbers instead of 3-digit numbers. Or you can say pick the minimum or maximum. You can keep changing those things too, right? Or you can come up with other ways in which you can make it more and more challenging. But I think it'll be fun, right? It'll be another game that you can code up and you can play with your friends. Or you can play on an iPad, you can play on a phone. Or if you're traveling from one city to another, you can play this on a phone with your fellow passenger sitting next to you, right? Hey, what is the minimum number? You got 5 seconds, okay? And so all of these cool things become possible. It's very interesting. All right, so whenever Charlene is ready, we can start coding this thing. And I think it'll be fun. Okay, so if you guys do you guys foresee any problems with the logic that I just described? Does it all make sense? Is it okay to yeah? And while Charlene is setting up and sharing a screen, let's also try and line up someone for Tuesday. Okay, who wants to code Tuesday? Right, Mohammed has coded, Erica has coded, Karthik, have you coded? By the way, the lighting is really poor because of the backlight, right? Because I think you got a window open in the back and it's really, really bright. Yeah. And so the inside, the light, yeah.
It's not even the windows open. I have the blind drawn, but
Yeah.
the light just leaks through.
Draw the blinds or something.
I'm gonna try. There we go.
Yeah, that's much better. I got there. Yeah. Oh, I'm back. And hey, Google, connect to my computer. Hey, Google, connect to my computer. Right. So, hey, Google, connect to my computer.
All right, looking for paired devices.
Okay, so did you code, Karthik? Have you coded?
No, I don't know if I.
No, you'll be fine.
learn
Not today. Not today. It's Thursday, but don't be absent just because you're lined up for coding and all. Okay, so it'll be very simple. Talk to anyone. Okay, maybe after class today, you can talk to Charlene and say how was it. Okay, and so many people. Mohammed coded on. Mohammed, you coded in the first class, right? Yeah, Mohammed coded, all these people. Where's Omar? I hope, he said he had COVID. I hope he's okay, right? So someone should reach out to him, send a DM saying, hey, Omar, are you okay? You didn't turn up in class today, okay? Hey, Charlene, pick up the screen anytime you're ready, okay? So Karthik, Elijah, you didn't code. Did you code, Elijah? Have you coded? No, I don't remember you coding, okay? So you should also be getting lined up to code in class. Matt, I don't know. I'm starting to, because more people are coding in class today. I'm losing track of who actually coded and who didn't. I can't look at the videos. So you got to remember these things. Oh wow, Charlene, was that a C line or some other IDE that you had up there before? Before this, it looked very different. Anyway, it doesn't matter. This is a private browser window, I hope. Yeah, that window, that on the left. What was that? Was that is this a C Lion? Oh, it's Visual Studio. It's Visual Studio. VS Code. See. No, you can Visual Studio. Oh, so your microphone is still broken? Oh wow. Okay, all right, okay. So let's go back to online GDB. We'll code there. Okay. All right, so let's do the standard stuff. We're going to say, hey, Sabrina, you haven't coded either. Yes. Oh, are you guys, Karthik, Elijah, Sabrina, are you guys all okay with coding, next in the upcoming classes? Minghua, you good? Are you able to code? Yeah, yes or no? Right. Yeah. Hey, Hana, I think, well, you have a bit more experience, I think, so you can come later. But you should also be ready to code. Namrata has coded. Matt, you haven't coded, yes?
Nope.
All right, so I can remember that. Yuhao, you haven't coded. And then Simon has coded. Charlene is coding now. Nam, I don't even know if you're in class. Okay, you're just, maybe you're just logging in and taking off. So that's what I think anyway. Okay, so you got to be present and active in class. And I'm not saying you're on Reddit either. So if you're not posting on Reddit and you're not active in class, that is basically 0 for participation. So why should you? It's easy to get these points. Okay, why? All right, so remember, All right. So here's what we're going to do. Let's put comments on the top again, saying class code for today. Today we'll play a game. Today we'll code a game that will test the user's visual interpretation skills, right? Or visual, I don't know, visual reading skills, all right? So put a comment right at the top saying today's class code for, what is it today, 31st or 30th, right? Yeah, class code for the 30th of January. And today on the next line, you can say, today we'll code a game that will test the visual, I don't know what I said, visual something, right? The visual interpretation speed, visual reading speed, right? Or reading speed or something like that, yeah, of users. Reading speed of users. All right, great. Okay. All right, so so let's do our int main, and so on. Great, yeah. And then we'll also be using vectors, okay? Because we're going to use arrays. So hash include vector above, below hash include IOStream. You can say hash include vector also. Okay, so vector, and within angular brackets. Okay, so inside of main, here's what we're going to do, right? So you should all also feel free to just say, this is what we're going to do, and you can call out code. You shouldn't be waiting for me to do all these things, right? Especially as the class progresses and we're going lecture number, so you know, 5, 7, 8, and so on. More of you should just be stepping up to calling out the code also. All right, so in main, here's what I'm thinking we'll do. We'll have an infinite loop like before, and in this loop, we will first generate 100 numbers. Second, we'll find the minimum of those 100 numbers. Third, we will print out the 100 numbers in a matrix, in a 10 by 10 matrix. And 4, ask. 5. All right, good. All right, so we have the sequence of steps. We'll actually write out all the sequence of steps in comments so that even if we go to the end of class and didn't manage to complete everything, we still have the comments for you to fill out. Okay, so let's put comments in there first. So the first comment is, well, let's do while true, right? Our game, it will be an infinite loop. So yeah, while true, within parentheses, within parentheses. No, true is within parentheses. Yeah, the word true is within parentheses. And then you don't have to have a space before the true, before the opening parentheses, right? While true, and then at the end you can put a space and a curly brace. Yeah, and enter. All right, good. So here, our entire game is going to live within that loop. And so what we'll do is first open comments in there. Yeah. All right. So now we're going to say, fill our vector with 100 random numbers. Okay, 100 random numbers. Right, random, or just say random. Right. Okay. Good. Now, because we're using random, let's also use srand to seed the random number generator right at the top of main, right before the while loop. Before the while loop, after you enter main, hit enter. Yeah. At the end, yeah, hit enter, and then you can say up there, you can say srand, whatever that thing is, right? Srand time 0, and so on and so forth. Okay. No, you can say srand right there. Srand, open parentheses, open 2 parentheses, actually, two of those. One more, one inside of that, one more. And here you're going to say unsigned. And outside of that, yeah, there's a space. Time, open parentheses, 0 capital L. Yeah, and a semicolon at the end. Right, enter. Nice, thank you. All right. You know, I didn't want to say that, but you know, that's great. Thank you so much. All right, so we've done that. We've now what we need to do is inside the for loop. Also, let's also declare a constant so that it's nicer that way. So let's say const size t, const size t, size, oh, in fact, not const, okay, just say size t, matrix size, okay, matrix size, right, size t, space, matrix underscore size equals, let's start with a grid of 5 by 5, okay, this is simple, and then as you get bigger and the levels get more difficult, you can say my matrix is not 5 by 5 numbers, 25 numbers, now you go to 36 numbers, right, and then 49 numbers. So the matrix gets bigger and bigger so that it's harder and harder to spot the minimum. Okay, so we'll start with 5, right, 5, and then put a semicolon after that, and put a comment saying put a comment on the same line, we'll start with 25 numbers. We'll start with 25 numbers in round 0, in round 1. 25 numbers in round 1. Yeah, okay. All right. Now hit enter. In round one, hit enter. And I'm thinking, you know what? Yeah, all right, good. So round 1 and so on. Okay. Matrix size is 5. Yeah, also you can say no, we don't have to have a round number also. I'm thinking aloud here, and let me know if you don't want me to think aloud and all. What I was thinking was, should a round number also be one of the variables? We'll get to know that later, and then we can make adjustments if necessary. Okay, now let's go into the while loop again, and after the first comment, hit enter. Put to do there. No, on the next line after the comment, you say open, the code, the comment, and then say to do in all uppercase. To do all uppercase. All right. Now 2 blank lines. Well, 1 blank line. One more blank line. No, you don't need a comment because that to do part is, we're going to do that. Right. One more blank line. Right. One more blank line. Enter. Hit enter. Right. Now open a comment, and in this comment, we're going to say. Print out the vector as a matrix. Okay, and I'll show you how to do that. This will be in 2 nested loops. Okay, this part I will do. Okay, again, put a to do there, but I will do this. I'll show you how to do this. Okay, unless one of you know how to do it and you want to do it, that's fine too. But I'll show you how to do this. On the next line, say to do again. On the next line, you can say to do. Yeah. All right. So and then blank 2 blank lines after that too. Thank you very much. Yeah. To do, and then a couple of blank lines after that. Yeah, blank two blank lines after that, just like the previous one. No comments, just blank lines, because we'll fill it in. Yeah. All right. Now, what we want to do is right now open comment again. Get player names and their guesses. Get player names and their guesses until one of the players is called no more players. Until one of the player names, one of the players' names is, you can leave out the called, and players' names is, and within quotes, you can say no more players. Within quotes, you say no more players. Okay, that's all. Right now, and then to do, and 2 more blank lines. Okay, now we got the guesses. Now you've printed this, and then oh, I see. So oh, I see. We're not going through many players here, right? We're just doing 1 player, and all right. So this version will keep it simple. Okay, we're not going to go through many players. Oh, what is this game, by the way? It's minimum. All right. So this is really cool. It's shaping up to be really cool because, right. So we'll do the simple version of the game first, in which it's 1 player. Okay, not multiple players, 1 player, and they win or lose, meaning they got it or not. That's all. Okay, just one player. And when this works, we can turn this into a multiplayer game in which you have this loop where you go and say, well, all the players. Well, you can't actually do that really, because it has to be a single player game. Because after the first players had their guess, the second player will have more time. Would have had more time, right? This player took and entered their guess in 5 seconds. The next player already has 5 seconds to look at the matrix right before they. So it's going to be a one-player game. So let's actually change line 19. On line 19. You can just say enter a guess, right? Get the player's guess. We don't even need to know the name of the game, right? Name of the player. Get the player's guess, right? We'll just say get the player's guess. Get the player's guess. One player. Get player guess, right? And this is one player for now, right? So one player, and get rid of the entire everything after that, right? We just say no more. We don't do that. Okay. Get player guess. Okay. So this you know how to do. Now, before we get the player guess, however, we need to sample the clock to see, how many, right? So on line 18, go to line 18 and hit enter. Right? Immediately after printing out the matrix, you're going to sample the clock and get the time, right? So you're going to say, you say size, we'll do size t now, right? Size t, timestamp 1, TS1, right? TS1. You say timestamp 1, up to you. Yeah, equals time, and then 0L, just like you had before, 0L, right? Semicolon, right? This is the number of. You can say this is a time. This time, it's very clear, isn't it? Do we need a comment there? Because we're going to do 2 time samples. One is before the player enters the guess, and one after, right? And then the difference between them is how long the player took, right? So get player guess. Now go to line 21, hit enter one more time, and one more time, right? Open comment, and say. Right. First, check if the player's guess is correct. Oh, and we needed one more also go to line 18 and hit enter. Go to line 18 and hit enter. One more thing I forgot, right? Here, comment again, and we say find the minimum of the 100. Find the minimum of those numbers. And we'll make some changes along the way. Well, on line 13, where you say 100 random numbers, you say n squared. Okay, capital N. No, you say n. You say n times n, and you say n times n instead of 100. Just say right instead of 100. You say n times n. Yeah, okay, that's fine. N times n. And then where you say size t matrix size equals 5, change that 5 into n. Oh no, change the matrix size into n. N equals 5, not n equals 5. Size t n equals 5. You can actually double click instead of clicking and dragging. Just double click, it'll get the whole thing. Yeah, right. N. Just say n. Right. So all right. So n is you guys 25 numbers. Okay. So now and then we have find the minimum of the numbers in the matrix. Right. So after line 19, hit enter one more time, and say to do like before. Right. Now Charlene's comment that she made later on makes more sense, right? Because she said satisfies condition. Now everybody knows what that condition is, right? Is the minimum actually, right? Now after that comment on line 26, hit enter. No, not there. On line 26. On line 26, hit enter. Right? So you're going to say, yeah, if the guess is not the minimum. If the guess is not the minimum, say so right away and exit, right? Say so right away and exit. Saying sorry, right? So you got to say sorry, you lost the game or something like that. Way you can come up with a message later on. Okay. Print sorry and exit. Okay. So now we know that they got the number, but in order to win the round, they need to do two things. They both have to get the number, but also need to get it within 5 seconds, right? So we need one more variable. So on line 10, hit enter on line 10 and say, yeah, there you want to say size t, time allowance, size t, time allowance, right? Time underscore allowance equals 5 and semicolon, right? 5 semicolon, and put a comment there saying initially the players get 5 seconds. Initially, players get 5 seconds to find the minimum. Yeah, and then later on, you know, in advanced rounds, you can start reducing that. You get 4 seconds, 3 seconds, 2 seconds. Okay, so all of that will be fun and keep the players on their toes. Yeah, all right, good. So now line 28, right? Line 28. Yeah, you can do to do there too. To do, put it to do. Right. So one more blank line, two more blank lines there. Right now, now check. Now get the time. Now get the time. Now get the time again. Oh well, we'll do that. Right. Size t. Now you actually just say size t timestamp 2. So size t timestamp 2. No need for comments there. No size. We just say size t. In fact, copy. Triple click on line 23. Triple click on line 23. Yeah. 3 clicks. 3 rapid clicks. Right. Is this a PC or a Mac? It's a Mac. Right. Now hit Command C. Command C. Now triple click. Triple click. No, don't do that. Don't do that. Triple no. Right. Type some junk there. Type some junk there. Where you erase that line, right? Just type some junk there. I want to show you something, right? Type some junk there. No, hit enter. Hit enter. Hit enter one time. Hit enter. Type some junk there. Right. All right. So you want to get rid of that and put that back. The best way to do it and not mess up your indentation and all is triple click on that line now. Triple click. Triple click. 3 clicks. Now paste. You'll get the right indentation automatically. Paste. No. Well, you didn't paste. Triple click there. Copy. No, not 4. 3 clicks. Copy. Now triple click on that other line on line 31, and then do a paste. Triple click and paste. 3 clicks and paste. It's a habit, right? That's why. Yeah. All right. So when you do, it's a habit, and once you get the hang of it, it's like very simple and quick, right? So triple clicking and pasting will preserve the indentation. Now change the timestamp 1 to timestamp 2. All right. Now on the next line, you can say size t elapsed time, right? Size t elapsed time. Elapsed time equals timestamp 2 minus timestamp 1. Yeah, timestamp 2. No, timestamp 2. Timestamp 2 space minus timestamp 1. So far, is everybody clear? Yeah. Now on the next semicolon after that. Right now, you have, one more blank line, and now you can put a comment there saying, check if elapsed time is less than time allowance. Yeah. All right. So now less than. If not, say sorry and exit game. Yeah. If not, say sorry and exit game. Right. Change the comma into a period and make the if capital I. Samuel White, you know, one of our English professors. So comma spliced. All right. So all right. So this way it looks much better. All right. So I think, I don't know. Right. And now if so, if you have not, so enter, and then to do again. To do. All right. Now blank lines. Now open comment again. I say if the code has reached this point, it means both. It means the player's guess was right, and they got it in the allotted time, right? Yeah. Right, yes, exactly. Okay. All right. So now you can print a congratulatory message, right? So you can say print a congrats or hooray or something like that. And one more thing we need to do after that is increase the size of the matrix, right? So you're going to do what was that we call it, matrix size? No, you can just do that right there. You don't need a comment there. No, put the comment there. Put the comment there. Like whatever you're planning to type is fine. Okay, just go ahead and do increase matrix size. Right on the next line, you can say plus plus. What is that variable? Well, we called it something. We call that variable. What did we call that variable? The matrix size.
It was n.
Oh, it was n. Right. Plus plus n. Plus n. All right. That's it. And no space between the plus plus and the n. So that way. All right. Great. Semicolon at the end. Semicolon at the end. Enter. And then it should go back to the top of the loop right here. That's it. That's the end, right? So you can close. Is the while loop closed at that point? Further down, can you scroll down? Yeah. All right. So we can get rid of the blank line. Yeah. Right. So I think that is the while. And after the curly brace, you can just say return 0, and then before the return 0, you can say see out. Thank you for playing. Well, what is this game? What do we call it? Find min. No, we should call it something more fun than find min, right? Call it mini, right? Thank you for playing mini, right? We'll call it mini, right? So MINNIE, like a Minnie Mouse. MINNIE, and then two left shift. Left shift is 2 less than signs, and then a semicolon at the end. All right, so that is it. That's our entire game. That is our entire game. What time is it now? Well, we haven't coded it, obviously, but but I'm thinking about it. It's only 9:14. We got a lot of time, and these to-do things, I think, right? They should, assuming I may be wrong. I think each of the to-do things will probably take you guys not more than 5 to 10 minutes to code, right? 5 minutes, you're going to be done with it. Each one of those, maybe more. I don't know, right? Yeah, thank you, Charlene. So here's what you should do, each of you, right? Now Charlene is going to share that. Now each of you have to pick one of these to-do items, right? Well, before that, I will code the what is it? I said I'll do something. I forgot what I said I'll do, right? I'll do that and then I'll hand over. But when that's done, each of you pick one of those to-do items and code for about 5 or 10 minutes. And when you all have agreement saying I've done that, then Charlene will pick up the screen again, or maybe she already has the screen, right? And she's going to say, "Hey, Minghua, what do you have in the first to do?" Right? And then you'll click on Minghua's link or whatever it is, get that, and put it in the first to do. Right? You'll basically get blobs of code from different people and put it in the different to-do items, and your program is complete, right? And each one of those will probably take 5 to 10 minutes, right? And if anyone is stuck, obviously, we can all dive in and code together also. So everything is possible, but I think this has a very good chance of, reaching closure today, meaning we'll be able to complete the game and actually play it too, right? So what was it that I was going to do? I said we'll find the minimum, right? In fact, better than that, who wants to do it, right? Does anybody want to do that to-do part where we find the minimum of numbers in the matrix? Okay. Well, let's start with the first one, right? Does anybody want to fill the vector with numbers? Okay. Who wants to write a loop that will just fill the vector with numbers? Yeah. Raise your hand.
I thought you were doing the print out the vectors and matrix with the 2 nested loops. Is that?
Yes, yeah, I'll do that.
Yeah.
Yes. I'll do that. Yeah, that's what I was going to do. I forgot. Yeah. Right. So I'll do that. Why didn't I do that? Okay. And after that, you guys can take over. So where are we going to print out the numbers? Yeah, there you go. Right. So it's a 2 nested loops, and it's very, very simple, straightforward and simple. And after, do you already know how to do this? Okay. If you already know how to do this, raise your hand. It is simple. If you don't already know how to do this, after I show you how to do it, you will think, You're going to kick yourself in the butt and say, wow, it was so simple, right? I already knew this, right? That's what you'll say. After I show it to you, you'll say, this is, I already knew it, okay? Do you want me to show you how to do it, or do you want to do it? All right, I'll show you how to do it. All right. So now get rid of the to do, and we're going to print this, right? So get rid of the to do, and we're going to do get rid of it. Yeah, get rid of it. We say for size t, I equals. For the for syntax is everything is within curly braces, right? So for and then no space also before that. Oh no, within parentheses. I'm sorry, Charlene. Okay, within parentheses and no space before the parentheses would be nice, right? So for size t, I equals 0. No, standard syntax, right? Standard. No. Don't close the parentheses after size t. For size t, space I equals 0. Semicolon. I less than. I space less than. Less than n star n, right? And in this case, n star n. Don't put space. Yeah, there you go. That's right. N star n is like n squared, and even though, right? So there's these rules we're trying to we seem to be implicitly following, right? Putting spaces on both sides of operators and so on. But here we broke the rule, right? We broke the rule and said, n times n, don't put spaces on both sides. Yes, but these are things that every programmer has, right? There's stylistic conventions that and yours might be different, and you'll evolve your own style too. Right, saying, oh, in this place I'm not going to put a space, even though the rules say I got to put a space, right? Why? Because it's tighter, it's n squared, and so we need to know it's n squared, and so these are things that you'll pick up on your own later on. Okay, so we won't dwell on that anymore. So semicolon space I plus plus. Now I think for beginning C++ programmers, this line here, line 18, right, doesn't have to be n star n. In the middle it could be something else, but basically the starting part for open parentheses size t I equals and so on, just that line, only that line. I think it behooves, right? It behooves C++ programmers or aspiring C++ programmers just to write that line out blindly, right? Not in any program, just write that line 50 times. Right, open an editor and say for size t I equals 0, blah blah blah, right? For size t I equals 0, 1 2 3 4 50 times, right? I think it is very useful, because that is going to be used so many times in your life as a programmer that it just helps to commit that to memory. Okay, just saying, oh, this is where the C# key is, right? Your finger needs to know that. You can't say, oh, I know, where is it? Okay, it doesn't work. Your melody is gone, right? So that is very important. You got to do it. Practice. One time. Programming is an art, and art is learned by practice. One time I used to have this friend I have, she's a dancer, and one time she told me I was practicing that for 6 hours nonstop earlier today, so I'm totally wasted. Okay, and she told me that one day, and I thought, wow, okay, and that is something that is physical movement, right? Imagine doing something that requires physical movement for 6 hours a day. Now, I thought I could never do that, and she did that, but she said that's what it takes to get perfection in an art, right? Because art, many times you will see out there, right? You will see art that is okay, it's nice, fine, okay, it's good. It's good to stand and appreciate it for, I don't know, 10 minutes and go away, right? But some of these artists I know, they're not happy with that, right? They're not satisfied. It's not enough for someone to stand there and wonder for 10 minutes and go away. They need it to grip the mind and live in their head even after the person has gone home from the museum, right? They need that piece of art to come in their dreams. And so what they do is they're not happy with something that is just passed. They want to be perfect. And to reach that perfection, which is that from going from 99.9 to 100%, or 99.9 to 99.999, right? That takes a lot of time and practice and perfection. And somehow, after a long time, they just bring themselves up. They bring themselves to just repeatedly doing that, just like a robot, mindlessly. And even though your mind is not, well, you got to be occupied a little bit, but with what you're doing, it'll just become second nature to you. And that is why I think programming, it is not enough. Just even, I don't know, maybe in math, not so much in math, in programming, right? Programming, you got to practice. Even though you know how to do it, it's not enough. Okay, that is a mistake that lots of programmers do. Lots of students, my students also done, right? They say, I know how to do it, I'm not going to do it anymore. right? I can pass the exam. Well, okay, well, you pass the exam and you forget it after that. But so the way to do these things is always to, well, after you know something, after you've sequenced all the notes, right? You got to play it all in sequence 100 times. Like that. Okay, so you got to keep practicing. Oh, we've migrated to Visual Studio now. Okay, cool. All right, so here's what we're going to do. Oh, Charlene, you want to type it? Great. Okay, so Charlene is going to type out. Charlene, is my guess right? You want to type out this loop on your own? Yes or no? I don't know. She's doing it, so I
No.
think it's a yes.
Apologies. I was just practicing while we were instructing.
No, that is it. That is exactly what we should be doing. That is what every one of us should be doing, right? So practice is blind. What is it? Practice leads to perfection. I don't know. My grandfather used to tell me that practice leads to perfection. Well, not in English, obviously, but yeah, English also, right? It actually works. Practice leads to perfection, right? So yeah, plus. I can read the font, so well, maybe I should change my glasses. Okay, my magnifying glasses. All right. Okay. Or maybe you can also hit, well, you changed. All right, so that's good. So size T I 0. All right, so here, do you want me to code the rest of it, Charlene, or are you planning to do it here? I'll do it. Okay.
I'm going to be honest. I'm not very.
Right, don't worry, right?
Good.
That's fine. Everybody should be honest, okay? So I'm totally honest, and I will say if I don't know something, I'll also say it, right? There's no shame in this, right? We're all trying to learn how to do this, so it's important to actually say, even if you, right? So that's great. Okay, so on the next line, here's what we're going to do, right? So hit enter. In fact, this for loop, space, and a curly brace. It's going to be a nested for loop. So we're going to have two for loops, one inside another. So put a space and a curly brace, hit enter. Now we're going to have another for loop. Okay. So you say for size T, J equals 0. Right? J. Say J less than N, right? J less than N. J plus plus. I haven't thought this through, obviously, right? So so you can see what's going on here. Okay, now curly brace after that too. Let's just like the previous one. Curly brace at the end, just like the previous one. Yes, the space and then a curly brace. Space, curly brace. No, curly, open curly. Opening curly brace. Yeah. Right. Enter. Now here, what we're going to do is print the number and a space, and then if we have printed, what is it? Oh yeah. All right. So for on the previous line where you say J less than N, you want to make it J less than. Oh no, that's correct. Perfect. Fantastic. Okay. All right. So it isn't right. So you want to say print, not print, C out. I'm sorry, C out. Left shift. What is we used something called set precision, set width. Okay, I think it is set width. Set fill. Right. So I think Justice did some Googling and found out. Okay, set fill. Open parentheses. No space. Just open parentheses because it's part, right? And then you want to say 0 within single quotes. 0 within single quotes. No, within single quotes. Between single quotes, right? So put a single quote on this side and a single quote on that side. I think single quote is the same key as the double quote, except no shift. Yeah.
I'm not quite sure I understand.
Yeah, so the single quote key, the single quote,
Oh, okay, apologies. I understand.
Yeah. Oh, you thought it was a quote, C-O-A-T. No, so a single quote. No, single quote. On before 2, before the 0 and after the 0. Yeah, all right. Now after the parentheses, left shift. And I think it's called set. I think it's set width or set precision. Is it set width or set precision? I don't know. Well, I wish Justice was here because he actually looked it up. I think it's set width. Set W. Type set W, and then we'll see what we get in autocomplete. Set W. And type set W. No, it's not. Set precision. Maybe it's. I think it's set width. Okay. I think it's set width. No. Set width. I think it's set width. set width, I think, and then within parentheses, you say 3. So what that means, each number is printed in a width of 3. And if the number doesn't have 3 digits, it'll be padded with zeros. That's what that means. Yes? And someone should do a Google and find out if this is the right syntax for that. I don't know if it's set width or set precision. Someone find out and let us know. Okay. And then after that, you want to say left shift space. No, on the same line, you can say left shift space. In fact, you know what we'll do? We'll put the space before, right? Put the space on the front so that, our matrix will actually be off, indented in by 1 space or something. Put the space after the cout. Go to the beginning, immediately after cout, and you say a space within single quotes. Or double, doesn't matter, but great. And all right, so it's going to print a space and then the 3-digit number, and then at the end you can put a semicolon right there. You put a semicolon. No more left shift after that. Put a semicolon, right? Now, in fact, what we can do is get rid of the curly braces for the inner for loop. Right? You have the for loop, the outer for loop, and the inner for loop. They both have curly braces. Get rid of the curly brace on line 19. On line 19, get rid of the curly brace because there's only one statement for the for loop. Right? Now, after the for loop, you can get rid of the, there you go, right? So here you want to say it will exit the inner one after printing 5 numbers, right? N is 5 initially. So it's going to print number 1, number 2, number 3, number 4, number 5. And then it comes out of the log, out of that loop. There you want to print a new line, right? So so indent back, backspace. Right. So now you can say cout, end L, right? Cout end L, cout left shift end L. Right, that's it. Now you can get rid of the curly brace after that, right? Get rid of the curly brace on the next line. Right, okay. Now that essentially prints the matrix in a line of 5 numbers, 5 numbers, 5 numbers, 5 numbers, 5 numbers. Yes or no? Wow. What is it? It's a spring already. I don't have spring fever, but doesn't feel like a cold. All right, good. I think that is line 26. You have something called min. What is it? Get rid of that. Yeah, line 26. Get rid of that. And the reason I said that is because everything else in this program right now is ready to be compiled and run. The game is not going to work, obviously, because there's a whole bunch of to-dos. But we don't have anything that's syntactically incorrect. So if we run it now, we should at least see the matrix show up on screen. Yes or no? If we run it now, we should see the matrix show up. Yes. So I put a semicolon. Semicolon there. I think if you run it now, you'll see the matrix. You should see the matrix show up on screen. No. All right. Let's fix that. Oh, yeah. After J less than N, you have a comma, not a semicolon. All right. You should have a semicolon, not a comma.
Also, I think last time with Justice, we used set precision.
It is set precision. Thank you so much, Erica. Was it Erica? I wasn't looking.
Yeah, it was me.
Yeah, thank you. Right, set precision. All right, good. Now try running it now. Some more. Oh, yeah, you need to go right to the top. Include, hash include, and then after IOStream, not after vector, after IOStream, hit enter. Now say hash include IO manip, MANIP, manipulation, right? MANIP, right? Close, and then hit enter so that the vector, the STL is separated from the IO libraries. Okay, that's fine. Oh, good. Something is happening. Okay. Oh, and it's in an infinite loop. Oh, because we don't have a break. Yeah. Okay. No, kill it. We don't have a break and all. Okay. Kill it. Now, go to that place again. Did we fill we didn't fill the vector with numbers. We just said, print it out, and we didn't fill that number, right? So we need to do that obviously before we run it. So let's fill the vector with numbers. Does anybody want? That's the first on line 16, right? Now we're going to replace that to do with another for loop. It's going to be a very tight for loop. Get rid of the to do. We don't need the to do there anymore, right? So you say the same kind of for loop again, practice, right? For size t, bam, 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 I squared, n times n. But here you're going to say do we have a vector of numbers? We didn't declare it. Oh, we didn't declare a vector of numbers. Okay, so go, So go to line 13. Go to line 13. Line 13, and then say vector. No, vector within angle brackets. Within angle brackets, you're going to say size t. Within angle brackets, you're going to say size t. Angle brackets. Yeah. Yeah, angle brackets. Less than. Yeah, size t, size underscore t. Yeah, close angle bracket. Spaced. And you can say numbers, right? In plural, numbers. And semicolon after that, and then enter. Right? Now we can go to line 17, fill it out, right? Yeah, that's fine. That's fine. So I equals 0. I equals 0. In fact, it is exactly what you have on line 20. You can do that trick again, right? You can triple click on line 20, triple click on line 16 and paste it, right? Triple click on line 20. 3 clicks, copy, and then 3 clicks and paste. 3 clicks and paste. No, don't click and drag. 3 clicks and paste. The reason I say that is really, now it may not make a huge difference, right? But a few milliseconds, you're saving a few milliseconds by not clicking and dragging and clicking and triple clicking and pasting. And the reason it is so important is because for 2 things, 2 reasons, right? And you'll appreciate these reasons later on when you're a more hardcore programmer who needs to get your idea out as quickly as possible, and typing, and then your fingers are really getting in your way. Your muscles are in your way because they're too slow for your mind. Yes. And so you'll appreciate these things then, right? You say, oh, I want to thank Anand for, teaching me the value of it, this thing then, right? So you'll see that this is important because, muscle memory, clicking and dragging, think about it. Clicking and dragging requires multiple use of multiple different faculties in your head. Your eyes have to be focused on whether you're dragging the right amount. Yes. And your muscles have to stop when you get all of those things, gross movements, really, really slow. Like mechanical motion, right? Whereas everything else we're doing in our mind, electrons, super duper fast. So what programmers tend to do, the habits they pick up as programmers evolve in the evolution of a programmer is that they start off with lots and lots of skills that are muscular and a small amount of skills that are mental. But over time, the mental skills keep getting bigger and bigger, the muscular skills getting smaller and smaller because less need for this, more need for that. Does that make sense? You'll actually see this unfold in your own life, right? As a programmer, you'll see this happening to you. Most people are not aware of it. And they realize, 20 years later, they'll realize, oh, I'm coding very differently now. What happened in the middle? They don't remember, right? So, but you'll actually see this happen. You'll see this happen and you'll say, wow, okay, I know what's going on. Okay, now in there, you don't even need the curly braces now because you only have one line, right? So get rid of the curly braces. Not there. Line 17, get rid of the curly brace. Yeah, on the next line, indent in, and all you're going to do is numbers dot pushback. Indent in. Say numbers dot pushback, push underscore back. Right now, you're going to generate a random number and put it in, and the random number is going to be between 0 and let's say 1000. Yeah. All right. So let's all right, we'll do this and then we'll declare the variable. Okay, open parentheses, rand, open close. Immediately after rand, you say open close parentheses, right? And then space outside of the parentheses. Outside of the parentheses, space, percent sign. That's a modulus operator. Let's take the remainder. Okay, remainder. And we're going to say max underscore number, all caps, max underscore number, all caps, max number, max underscore num, max num, right? And then semicolon at the end, we put a semicolon. And now let's define max num, okay? So after size t time allowance equals 1. Oh, after size t, after line 11, right? Hit enter after line 11. Yeah, there you go, right? And you say const No, not even const. Size t max number. Size t max number. Max num. Size t max num equals 100. In fact, you know what? As you get, as the levels keep increasing, maybe we'll also change the max number. Could be 1,000 later on, right? In fact, yeah. So semicolon there, and what we'll do, because it's not a constant, we'll just change max num to all lowercase, like Charlene originally started to do, and I corrected her, right? Just say max num all lowercase, because we're going to be changing that later on, right? So and then there too, right? On line 19, change that to max. Right now, I think if you run it, the vector would be full of numbers, but we need that exit statement too, right? So after on line 26, hit enter. On line 26, hit enter. Now let's just say exit 0, right? Exit 0, exit, exit, open parentheses, 0, close parentheses, semicolon. Now, only one, yeah, right. On the same line as the exit. Put four of those comment signs, 4 comment signs, right? And you say you want to say temporary, right? So say something, well, temporarily, yeah, temporarily here, right? Yeah, temporarily here. Because the reason here we're putting it there is so that if we run it now, it's not going to an infinite loop, right? It'll basically be here. Now we also need a condition for getting out of the loop. So what we need to do is further down, further down. Let's put that there too, right? Find the minimum. All right, that's even more. Where you get the player's guess. Yeah, to do, right? So what you can do is above that line. I'll flesh out the comment a bit more so that you know you have more information as to what to do, right? No, below get player guess. Yeah, there you go, right? And hit enter. You're going to say print the prompt, get the number, and if the number print the prompt, get the number, and if the number is negative, say thanks and exit, right? Let's say thanks for playing and exit. Get the number. If the number is negative, we say thanks for playing the game and enter, exit. If the number is negative, thank the player, and exit the game. Right, and then your num is NUU, right? So fix the typo. No, the second one after that. Okay, right. So that's all. Now we have that exit there. Now, if you run it now, I think it should print a matrix of, those numbers. Great, excellent. Thank you. It looks very nice, right? I think if you run it now, Charlene, we should see the matrix show up, right? I think so. I hope. Anyway, let's see what it printed. It didn't print anything. Run it one more time, please. I want to see what happened. Okay. Well, it's 5 by 5, 5 by 5, and a max number is 100. And why is it not? I shouldn't be the only one debugging it. Okay, so other people should also look at the code and try and find out or try and guess why is it not printing? It is supposed to print something. Why is it not printing these numbers? Okay, so yeah, of course we're not printing the numbers. That's why it's not printing the numbers. Okay, after set position 3, we need to print the actual number. So after on line 24, after set position 3, you want to print after set position 3, right? You want a left shift. Yeah, no, on the same line, on line 23, on line 24. Instead of the semicolon, you want a left shift. No, get rid of the semicolon. All right, you want a left shift. I think what do we call a vector of numbers? Numbers square bracket I. Numbers square bracket I. A semicolon after that. Semicolon after the yeah. All right. Now we also need to do one more thing here. Now triple click on line 25. Triple click on line 25 and copy it into your buffer. No, triple click. Yeah. Now go to end of line 26, hit enter. Right now, triple click there and paste it. Triple click there and paste it. Oh, maybe you shouldn't have triple click. Just paste it with unintended. Just unintended. Remove the spaces in front of the CO. All right. Okay, great. Now the reason we have that last thing is there is that it'll print 5 numbers space new line, 5 numbers new line, 5 numbers new line, 5 numbers new line. The last line it prints 5 numbers, but I think it does not print. Oh, it actually does print the new line. Oh, well, we'll have 2 new lines again. That's fine. Okay, good. All right. So let's run it now. I think we should see the matrix of 5 numbers. Okay, now can you make the size bigger? Why is it printing the same number? Oh, yeah. All right, so here's how we have to do this. Okay, it's printing the same number. Does everybody know why it's printing the same number every time? And because it's not printing the index, it is not. So it is printing. All right. We actually have a. Okay, all right. I'm going to do something here, which is correcting an error which in my code before. What I dictated to Charlene, there was an error, and we're correcting it. So bear with me here. It's very simple, okay? And it's going to be after you do it, it'll be after we do it, it'll be very clear. Hey, Charlene, go to the end of line 22 and hit enter. What we're going to do is now take that line, line 25, triple click on line 25 and paste it there. Triple click on line 25, paste it there. Paste it there. Yeah, paste it there. Adjust the indentation so that it is correct. Adjust the indentation because it belongs to the first for loop. Now, after that line, hit enter. Yeah, there you go. On the previous line, you're going to say on the previous line, you're going to say if, and within parentheses, you're going to say if I plus one percent n space percent n. So, yeah. No, I plus 1 could be no spaces there, and in fact, I plus 1 should really be within parentheses or on its own, right? Percent n space before the n. And then put the I plus 1 inside of parentheses on its own. The I plus 1, where you had the I plus 1, turn the I plus 1 within, mid that, there you go, right? I plus 1, and then this is uppercase n, all right? Uppercase n, percent uppercase n equals 0, right? Equals 0, double equals 0, right? On the next line, you're going to say C out end out. Right? The next line, you're going to say C out. And I think that's enough. We don't need 2 nested for loops. This will actually do it too. And you can get rid of the inner for loop, right? You can get rid of, we don't need the inner for loop anymore. Just say end out. End out, semicolon, right? Get rid of the inner for loop. Line 26, line 27 and so on. We don't need any of that, including the C out, right? Get rid of that. And then that C out needs to be indented to belong to the if, right? The C out that you already have needs to go to the right so that it belongs to the if statement. Now, here's what is going on. Tell me if you follow this very closely, because it's really important. All of you, all right? It's what is that for loop doing? It is printing the numbers, first number, second number, third number, fourth number. And the fifth number, after it prints the fifth number, that if statement below it will kick in, because the fifth number is at index 4, isn't it? 0, 1, 2, 3, 4. Yes or no? 4 plus 1 is 5. Yes? And 5 is divisible by n. N is 5, isn't it? Therefore, after printing every 5 numbers, it'll print a new line. So we have our matrix effect. Yes or no? Okay. Now, this may take, maybe 5 minutes of looking at the code and thinking, but it's very straightforward, and you should experiment. Okay, later on when you're in your own time, you should experiment, saying, well, I'm going to try and print out the matrix, but in a slightly different way. and see what the pros and cons of doing it this way, that way. What happens if I don't do it with this, if statement? All of these things you can try. And if you run it now, you'll see the full matrix. I think you should see the full matrix with different numbers. Why is it not zero filling? It should print zeros in front of the. Why is it not zero filling these numbers? Hey, Erica, or someone, should do a Google search. We need to know why it's not zero filling. Then, every number should be zero. Should have a zero in front of it. Also, where you have set precision 3, change the 3 to n minus 1, right? So no, change the 3 to oh, I see. Well, we'll leave it at 3 for now. Okay, we'll leave it. Why can someone tell me why? I don't know, right? I don't know why it's not zero filling those numbers, but we got it to zero fill before. Or maybe the set fill needs to go after set precision. Someone Google it, right? Please Google it. Find out how you can print a C in C++. How can you print a number with zero filled padding? Okay, yeah. Thank you, Charlene. Okay, zero filled C++. Yeah. Yeah, there you go. What does it do? Yeah, you just accept out. Yeah, further down, you'll see an answer. That's what they're doing. Set full 0. Set width. It's not set precision. Set W. Set W. All right, okay. That's what I thought. Okay, it wasn't set width. It was set W, right? So it's not set precision. Set W. Okay, good. Thank you. All right, so if you run it now, I think we'll see a nice matrix, right? There you go. Okay, so we've got the number. Can you increase the size of the console, the black screen, so that we can? All right, there you go. So 5 numbers, all of them are there. Okay, now we can print the prompt. Okay, now we can go to the to do after that. To do after where you say. Oh, we have to get the clock. We got the clock. We got the time, right? Now get rid of the exit now. We don't need the exit anymore, right? We don't need the exit. Triple click and delete. Yeah, delete. And then I don't think we need the C out because I'll leave the C out there. Okay, right. So find the minimum. All right, find the minimum. Right, find the minimum. We got to find the minimum. Who wants to do this, right? I let's say, wow, we're at 9:49, right? Finding the minimum is so easy, isn't it? Because raise your hand if you know how to find the minimum in that vector, okay? Because I'll tell you how to do it. Charlene's already trying to do it, right? Because itching to get it done. For all you have to do is first make a hypothesis saying size t min equals first number, okay? Size t min equals number square bracket 0, right? Number square bracket 0. No, I think we called it numbers, right? Numbers, right? A semicolon, and a comment on the same line saying our initial hypothesis, right? Our initial hypothesis about the minimum. Our initial hypothesis about the minimum. Right? On the next line, you're simply just going to, copy and paste that for loop that we had, triple click and copy that for size ti equals, right? Or maybe you should just type it in for practice. For size ti equals 0. Yeah, size ti equals 0. I less than n star n. I plus plus. Right? On the next line, you're going to say, in fact, it's not even I equals 0 because we already took 0. You start at 1. Right? Charlene probably already knows programming, right? Maybe in a different language. Because the way you can tell, right? One programmer could tell if the programmers have practice or not. So good. So for indent in, right? You're going to say is indent in 4 spaces, right? And say if min is you say if min is greater than, right? Within parentheses. Looks like Charlene, have you programmed Python before? I don't know. When I work with Python programmers, this is the thing that I run into all the time. They're always missing these parentheses and curly braces because in Python you don't have to do this, right? So if min is greater than numbers square bracket I, Yeah, on the next line, you're going to say min equals number square bracket I, right? On the next line, you'll say numbers, indent in, indent in, indent in, indent in, and say and min equals numbers square bracket I. Right? And put a semicolon and a comment on the same line, semicolon and a comment saying revising our incorrect hypothesis. Yeah, that's fine. Okay. All right. Now put spaces on both sides of the min greater than, so so that the greater than has spaces on both sides. All right. So at this point, we've printed out the matrix and we've also got the minimum number. Yes? Yes or no? Raise your hand if you think we have the minimum number. When the for loop exits, the minimum of those numbers will be in min. Yes or no? I shouldn't be the only one raising my hand because I'm confident it'll work. But all right, Erica. All right, who else? Who else? I need to see more people. Namrata, Sabrina. All right, quite a few people. Where's Hannah? I can't even see your. Hey, Hannah. Yeah. All right. Simon, are you good too? Can you see that? After this, we'll have. Right, good. All right. Ruja. All right, good. All right. So now get player guess. Go to line 39 and hit enter. I just want to see if you guys can easily do it yourself. Yes, you can do this, right? Again, raise your hand if you can. I'm going to leave this, okay? No, we won't do this. Put the two back. But I think because you got to say, in your prompt, you got to say, this is what you got to say, okay? So in the prompt, you will say, enter the minimum number within 5 seconds, or -1 if you want to quit, right? That's what you got to say. So you can say, yeah, and you can say on after line 39 hit enter. After line 39 hit enter, I say example, e.g., and say space, and then say no, so just say say, say example, say within quotes you can say enter the minimum number or -1 if you want to quit. Enter the minimum number or -1 if you want to quit. Yeah. All right. And then EG is E.G. Okay. EG is E.G. I don't know why is example E.G. Maybe it probably comes from some other language like French or something, right? Yeah. So EG, right? Latin. All right. Okay. There you go. All right. Okay. Good. All right. So let's go back to the code. Now, so that's what you're going to say, and then you'll get the number into some. You need a new variable for that, right? You need to have a variable called size t user guess. Yes. Okay. So now, and then to do, and then on the right side of the to, you say accept the user input into a new user variable called user guess, right? You can do a new. Oh no, on the same line as. Yeah, there you go. Yeah, so space, and then say space hyphen, right? Space hyphen, a dash. Yeah, space. I say accept the user's input into a new into a size t variable called size t variable called user guess, user underscore guess. Right, and then the users is apostrophe s, user apostrophe s. Well, no, accept the user's input, right? User apostrophe s. Okay, so that's your to do. So you guys can do that. Yes, right. Now, and then after that, on line 43 and 45, you're basically just going to check to see if the users, if it is equal to the minimum. If it is not equal to the minimum, you're just going to say, hey, I'm sorry, you didn't even get it right. No point in checking your time anymore, right? So and then so if the user, if not the minimum, you can say sorry and exit the game. That much. Can everybody do that? And then let's go further down, right? Now you're going to check if the user's guess, you got the guess and it is right. You want to check if it is, now you already know it's right. You want to check if the number of seconds is less than allowance, right? So again, you can do a check there. So after the to do, put a hyphen on line 46, space hyphen. So you say if elapsed time is greater than Yeah. What is it? Permitted time, allowance time, time allowance. I think we call it time allowance, right? No, time allowance. Time allowance. Time allowance. Print a message saying time exceeded. Yeah, print a message saying you got the right answer, but it was too late, right? I think we should say that, right? Print message saying right answer, but too late. Right answer, but too late. Sorry, right? Right answer, but too late. Sorry. But all right, be quicker next time. Sorry, you got to say sorry. Oh, there is no next time. You're going to exit, right? You don't have an infinite loop. You're going to exit, so you can say sorry and exit, right? Be quicker. Sorry, right? Yeah, full stop and then yeah, the full stop. I don't think there's a comma there, but I don't know. I might be wrong in my English, right? So you can fix the commas and everything later on. Okay, all right. So that you can do. That's it. I don't think there's any more to-dos. Are there any more to-dos in this game? Further down, do we have any more to-dos? That's it. Oh, this is it, right? You know, that comment that we made up there, that should be here. Yeah, triple click that, triple click. Yeah, and cut it. Cut it. And then you can just triple click on 51 and paste it there. Triple click there. Triple click and paste it. Paste it. Yeah. That's basically it. Yeah. And then if code reaches this point, and you know how to print the congratulatory message, right? Everybody's good on saying congrats, right? So we should say at that point on line 54, we just say congratulatory message and we exit the game. It's a real pity that we didn't get to play this game today, all right? But, you know, partly because I spent time early on talking with Namrata, right? About the previous thing that we did and doing that. If we hadn't done that, we would have completed it and played this game today. However, it's good that we didn't complete it because there are still lots of places here that you can, you know, complete it, your own versions. Now, your own version, each one is going to do a different version of this, obviously. So in your version, you can consider saying that, well, in my version, I'm going to do 4-digit numbers, right? Or in my version, I'm going to have many levels, right? If you clear it, I'm just going to keep increasing this. So many. This is the scope for this is endless, really, right? Or you can say it's not a minimum. I'm going to do maximum. Or you can go really challenge the user to say, here's 100 numbers. What's the average? Right? Find the average. And I got 10 seconds to find the average of all these numbers. So you can do, and you can even combine. You can combine this with the previous game if you're really up to it, right? If you can combine this with the previous game, saying, well, here it is. Find the average, and then 5 players are playing the game, and everybody's going to guess the average, but then they don't have to be right. You just have to find the closest number. The price is right, okay? Whose average is the closest to the real average? That's the winner. All of those, right? You can combine these things. The scope for, getting creative and trying variations here is endless. Yes or no? Raise your hand if you think there's lots and lots of things that you can do here, right? Yes? Great, thanks. Okay, so here you go. There's another fantastic opportunity to get, participation points later on, is try and complete various places where to-dos are there, right? Even collaborate. You can say, well, you know what, Hannah or Matt, right? Matt could say, Matt and Minghua collaborated, right? Matt could say, hey, hello, classmates. Minghua and I decided to work on this game together. So Minghua implemented that to do, and I implemented this to do, and together we combined it, and this is the working version, right? So the scope for collaborating, working together, and then making tweaks, adding bells and whistles, you can add sound effects, all these things, all of that is out there for you, all right? So I think we got it. It's done pretty much, right? Except for these simple things that you need to flesh out. I'm happy we left it here, really, because then we'll get a chance to play this game after you guys post a link to online GDB. I'll click on it and I'll say, well, I'm going to play it, right? I'm going to play it. And in fact, you can make it more interesting by when you say congratulations, you can also say you got the right answer, but you also got it in 4 seconds, or you got it in 3 seconds, right? So you can also say how many seconds the player took to find the minimum. And then maybe you'll do a 10 by 10 matrix, 10 by 10 matrix, and give the user 10 seconds to find the minimum, right? There, there'll be more scope for many players to play and say, hey, you got the answer in 7 seconds. I got it in 6 seconds, right? So you'll have that also factored in. And if you're really up to challenging yourself even more, you can look at, there's a call called clock. We're using time. Time is very granular. It gives you only time marks every second. but there is a a library called clock, right? Clock gives you time measurements in milliseconds or nanoseconds or something like that. So if you use clock instead of time, well, I'm not doing this because it's not directly related to CS2A, but you can research and find out. If you look, then you can say you got 5 seconds, but you got it in 4.72 seconds, right? Whereas, Elijah got it in 4.73 seconds, right? You got it in 4.72, and so you're the winner. So you can do that kind of fine-grained distinctions also, right? It'll be really, really cool. If we don't, we'll get a chance. I think we'll try and come up with a way to use clock in some other games we do later on. But that's basically it. So was this useful? Did you guys learn some interesting and useful things today? I'm looking forward to seeing variations of this program, okay? Well, Peter and his friend, they're both here. Right, so that's basically it. And if you have any questions, feel free to ask me now. Otherwise, I'm just going to look forward to seeing more and more of these things, in the forums, so that not only me, all of your classmates too, and especially the classmates who are not attending class, okay? Your classmates who are not in class, they should be able to go to the Reddit and look at all these cool programs that my classmates are posting, right? And I'm missing out on all of this. I'm going to go to the next class, okay? So the people will look at your programs and say, I want to attend, and you'll increase the attendance of our class by virtue of your awesome programs that you post in our subreddit, okay? So I'm looking forward to seeing all of those. Thank you all so much. And Tuesday, I hope to see you all on Thursday. Hopefully we'll have more ideas for other things we can do. Or, Liz will, Charlene will share the link, and we can pick up this program on Thursday, go over this, and fill in stuff that other people have done. Or hopefully you post your own version, we'll go with that too, right? On next class and do that. Thank you all, right? If you have any questions, ask me. Otherwise, great class. I enjoyed, end of every class, I'm saying I enjoyed it, but I want to make sure that you also enjoy it. And so you should let me know if any of this is. Share it on, hey, Sharon, share it on the subreddit, okay? Because the chat here will tend to disappear. Share the link on the subreddit, and then people can pick it up from there. Yeah, you don't have to do it now. You can do it whenever. Yeah. Thanks all. Okay. So is that it? That's it. What is it? It's 10:04. Again, thank you all so much. Right. I should go and apologize to all your next professors, saying I'm sorry, I didn't mean to hold on to your students for longer. But can talk to them. They're the ones who are sticking around. Thank you all. Okay. I had a great time.
I actually have a question.
Yeah, sure.
So the game that we mentioned earlier with using Amazon API, how do you get started with that? Because I was searching it up, and it was saying you have to make a developer account and maybe download.
Yeah, you have to. I think, all of these. The reason you have to make these developer accounts is that after you make the game, they're going to put your game in the shop, right? You make the game, it'll show up in the Apple Store or Google Play or the Amazon Alexa shop. Yes.
Yeah.
So in order to do that, you need to be set up as a developer. It is a little bit of a pain to do that, but it's worth it, I think, right? It's worth it. It's one time. So Google, right? Google how to get set up as come here. Yeah, right? So you just Google and say how to get set up as a Google developer, how to get set up as an Amazon developer. Lots of people have these guides. Just look through them and you'll find here's what you need to do. First of all, create an Amazon account. Link your credit card, create some certificate just to show that it is you, right? And so on. They'll walk you through this. Once you're set up, that's all you need. And then you can Google for tutorials on YouTube, right? Tutorials, how to program Alexa and how to write an Alexa script. And you'll find a lot of these tutorials. Just follow them, do some simple ones. They'll probably already have some simple tutorials for Hello World, right? How to make Alexa say Hello World. Right, so start with that, and I can bet that how to make Alexa say hello world will be 1,000 times easier than how to make C++ say hello world, right? Because C++, you got to get there and compile and things like that. These guys will make it easier because these programs, writing Google programs and the device programs are not meant for programmers. They're meant for lay users, and like creating Excel or Word macros. Ordinary users do this, right? So that's why the scripting languages will be targeted for ordinary users. They'll be easy. Since you're learning to program, that'll be like a piece of cake for you. But it'll look foreign initially, but it's actually 100 times easier than learning C++. So look at the tutorials and set up a developer account and do it. It doesn't have to be outside. It could be Google Play, Siri, whatever it is, right? And you'll get it too. If you do it, let me know, right? If you write an Alexa game, let me know. I'll install it. Okay. Assuming even if you're going to charge 49 cents, I'll buy it. Okay. I'll install it and play it. And thank you. All right. I'll see you guys on Thursday. I wish these classes were longer, but I had a great deal of fun. Okay. Thanks very much. See y'all.